My own little rebelliousness.
All right, so first, I got a request to go over some specific topics, so let's do that. So the topic is how to get the graph of f prime from the graph of f, and vice versa, how to get the graph of f from the graph of f prime. So let's suppose you have a graph of f of x, okay, and it's just a random thing like this, and let's say there's like an asymptote, and maybe it just does like a weird like piecewise thing like that. Let's say that's the function. Okay, and you're trying to graph its derivative. So the strategy should be first, identify points where the derivative is 0 or undefined. The derivative is 0 at high and low spots. So it's 0 there, and it's 0 there. Oop. Ooh, I didn't hear you, what? Okay, thanks. Bye-bye. And the derivative is undefined here because it's a discontinuity, right? So if the red stuff is the derivative, that's what I have so far. The next thing you should do is just observe in between these points. So like the interval to the left of that point, in between these points, and to the right of this point, and just see what the derivative looks like on those intervals. So like to the left of this point, if the pen is the tangent line, it starts out 0, has a positive slope, and it just keeps getting more and more and more positive. So the derivative might look something like that. I don't know if it's linear or if it's like curved, it doesn't really matter. They're not going to be that specific with it. They're just going to look for like, where is it positive, where is it negative? On the next interval, the derivative is always negative, and it starts out 0, a little negative, more negative, and then less negative, and then 0 again. So it might go like that, and like that. On the next interval, it's 0 here, and then it's positive, and then it's more positive, and more positive, more positive, infinitely like that. So that's the derivative on that section. On a linear part like this, or a piecewise linear part like this, the derivative is always positive, and it's just some constant number. So it's just like going to look like this. It's just a constant positive number. So that would be f prime. Does that make sense? Now, if they gave you the derivative graph and they asked you to find f, my strategy is a little bit different for that. So what I would do in that case, like say I have a graph, this is f prime of x. Okay, and let's say it looks like, I'm trying to think of like how to make it look different even. Let's say there's not an asymptote, but there is a piecewise part or something like that. So say it goes like this. Something like that. I don't know. And you're trying to determine what the shape of f of x is. Well, first thing to understand is f of x has a particular shape, but it might be a vertical translation of that shape anywhere up or down, right? Because of the plus c aspect of it, okay? When you're taking integrals. But anyway, my process is to calculate or to figure out the shape of the function is to make a first derivative chart out of this picture. Okay, so if I look at my first derivative chart in this case, like it's split up wherever it's 0. So it's going to be like split up there. It's going to be split up there, and there, and there. Whenever the derivative is 0 or undefined, that's where I'm splitting up my first derivative chart. And then I'm just going to look at it. This is negative because it's below the x-axis. I'm not looking at the shape of this graph. I'm looking at whether or not it's below the x-axis or above the x-axis. So this is negative, and then it's positive, and then it's negative, and then it's positive, and then it's negative again. Okay? So then I know that it's decreasing, increasing, decreasing, increasing, decreasing. Now the difference between these 3 critical points and this critical point, these 3 critical points, the derivative is 0, which means that it's a high spot or a low spot, or maybe it's a spot where it flattens out and then continues, but that's not the case here. But at this point, the derivative is undefined, which means it has to be either a corner or a cusp or a vertical tangent line, right? Those are the situations that have to occur at those points. I know it's not an asymptote because if f of x has an asymptote, then f prime would also have an asymptote. Okay, so I know it's not that situation. I suspect this one's probably like a corner or something like that. Okay, so what does this graph look like? It's decreasing, and then it's increasing, and then it's decreasing, and then it's increasing, and then there's a break in it. Maybe the function is defined here, maybe it's not, we don't really know. And same thing here, maybe it's defined, maybe it's not, we don't really know. But then it's decreasing again, so maybe it jumps up here even, and then it's decreasing. So something like that. That's the general shape of this curve. And so these questions are most often multiple choice, where they either give you f and say, which of these could possibly be the graph of f prime, or they give you f prime and they say which of these could possibly be the graph of f. They give you f, go with 0 points. Figure out the points where the derivative is 0, and then go from there to eliminate the choices. If they give you f prime, turn it into a first derivative chart and get a general shape of the graph, and then see which of the pictures fit that general shape. And again, it doesn't matter. Like in this red stuff, it doesn't matter whether the y or the x-axis is down here or whether the x-axis is right here. It could be either, because like if the x-axis rather happens to be here and it has this derivative, I mean it's the same as if the x-axis was here. A vertical translation has the same derivative. It's the same shape graph. Does that help?
Yeah, a little bit.
Okay. Any other specific questions? Okay, so yesterday we were doing this thing, right? Okay, so whose turn is it? Aiden's up. Don't be nervous. I don't want you guys to be nervous about this. This is judgment free zone, remember?
No, I'm not nervous. I don't care. Yeah.
Number 2. So there it is.
So I'm going to simplify it first. I'm going to take 3 out of the bottom, so this becomes x plus 4. So 1/3 integral 1 over x plus 4. Then this ln, 1/3 ln x plus 4. My apologies. Yeah. Let's see.
Okay, so remember I said I was going to ask hard questions. So what if there was no common factor in the bottom? Like what if it was 3x plus 11 in the bottom? How would this problem be different?
Then we'd have to like multiply it by 1/3 over 1/3, I think, something like that, and you get like x plus 11 over 3 at the bottom. To cancel it out or something.
Yeah, don't
Well,
usually with the
that's
three,
what-
pretty substitution.
Here, write this down. Integral of 1 over 3x plus 11. All right, so tell me again, like what's the answer?
Wouldn't you have to like multiply it by like 1/3 over 1/3, and then this would cancel out, and you get like plus 11 over 3.
Oh, that's the.
You're thinking of like.
That's interesting. That would work. I mean,
Yeah.
there's nothing
Yeah.
wrong with that, but that's not the easiest way to do it. The easiest way to do it is just think of it as It's like a constant, the derivative, you have to do u substitution, but the u that you're gonna pick has a constant derivative, so you just divide by that derivative. So the answer would be ln 3x plus 11 divided by 3. That's it. You just divide by the derivative of the u that you're doing. One other question. If this was a free response question, why might you get points taken off?
We didn't put, yeah.
dx, okay, I'm just making sure that you understand. Good. Any questions on that?
Yeah, when you were talking about like the second one,
Yeah.
it would be like 3x plus 11 divided by 3. The ln would be divided by 3 too, right? It would just be like what's in front
No,
of
it would be.
For the whole thing?
Yeah, it would be ln 3x plus 11 divided by 3. Be like that. Does that make sense? And you could actually think of this the same way. You can think of this the same way. This is going to be ln of 3x plus 12 divided by 3. Well, okay, well, then if that's the case, then why is it this? If I could have done that here, is this equivalent to that? What do you guys think?
I mean, different equations have the same derivative. So even if it's not, like,
That's a good point. How do you check to see if integrals are right? Take that. So let's try that. Let's try that. So if I take the derivative of this, I get 1/3 is a constant, and then 1 over 3x plus 12 times 3. That's the chain rule. Those would cancel. It's good. So that's definitely right. Right? Let's see if this is right. Oh, oops. This one is right. The 1/3 is a constant. And then 1 over x plus 4. And then this could be distributed, and it gives you the same thing. So yeah, so great. Yes, you're right. This is right, this is right. But my question is this equivalent to that? Or are they vertical translations of one another? What if this was just a simplification problem? Here's two ln's. Are they equivalent to each other, or are they vertical translations of each other? That's the question. If I take this, and I take this, which is it? Are they equal, or vertical translations? So why don't you think they're equal then? Oh, for that reason, because you don't know how you would turn one into the other. Gotcha, okay.
because if you get rid of the 1/3, well, it's not.
Like if you just multiply both by 3, they're
Right.
equal one another, so then you just have ln of x.
Okay, all right, so we have, let's look at them, let's try and make them look as similar as we can. The left, this one is 1/3 of ln 3x plus 12. This one is 1/3 ln of x plus 4. Yeah, I mean, essentially, we'd be saying that x plus 4 is equal to 3x plus 12. That's definitely not true. But here's how you could show that it's a vertical translation, and by how much. You could actually just factor out a 3 here. 1/3 ln of 3 times x plus 4. Then you could split this up to be 1/3 of ln 3 plus ln of x plus 4. So the vertical translation here is the ln 3. Well, actually 1/3 of ln 3, right? That's how much it's being changed, right? So just one second. So this graph right here is 1/3 ln 3 higher than this graph. Other than that, they're identical. Does everyone understand? Now, they're not asking any of these questions, but it's good to think about this stuff so that you know. It reinforces the fact that, yes, great observation. If the integrals are equal, then two functions that have the same same derivative are either equal to each other or they are vertical translations of one another, and it helps to think about which of these is. I think it's a good little exercise. You have questions, right?
We need the plus c for the green.
Yeah, absolutely. Yeah, for any of these, you need +8. Okay, any questions on that? That was a good one. Even though it was a pretty easy question, I think there's good questions that come out of it, all right? All right, who's next? Chala. 18. So 18 is a multiple choice, no calculator. Here we go. So without even thinking about it at all, like what type of problem do you think this is? Without even reading it. Part 2. FTC part 2, because it's an integral where one of the limits of integration is an x. So go ahead. Sorry.
The best you just substituted x for another 2. Yeah. Oh, but they make them harder than that. Oh, no, they don't.
What do you guys think?
Yeah, that would have done.
That's exactly right. So this is one. Wait, I'm not done. I'm gonna ask you a hard question. So this is one where, even though you have 2 minutes per problem, this problem should not take you 2 minutes, right? Definitely not. What if the question was different? What if it was, instead of from 3 to x, what if it was from 3 to 5x? How would this problem be different?
You substituted 5x?
Oh, yeah.
Yeah, you would substitute in 5x for t, and then you'd multiply the whole thing by 5. Like you'd have to put parentheses around the whole thing that's there, and then put times 5. Does that make sense?
Yeah.
That's the chain rule. What if it was the integral from 3x to x? How would that be different?
You have to do like top one minus the bottom one, substituting both and then multiplying by 5 and then 6.
Right. Yeah, I just said 3x and x, but yeah, you're right.
Sorry.
Yeah, absolutely. Everyone understand that? So there's variations on FTC part 2 that involve the chain rule, and there's variations that involve if you have a number on the bottom and the top. What if these were switched and you had the integral from x to 3? Yeah, the negative answer that you selected.
So what we did if it was 3x on the bottom and then x on the top?
It would be, okay, thank you. It would be tangent 5x secant 5x minus 1 minus tangent 15x secant 15x minus 1 times 5. Chain rule.
Times 30, right?
Oh, 3. Yeah, thanks. Times 3. Chain rule. That's not an exponent. I just ran out of space. Okay? Does that make sense? FTC part 2. Well, come on. Will it be a free response question? No, I'm very excited.
I have to be part of it. No,
All right, number 5. Wait, number 5.
So when I go, I just blanked out. Teaching.
There it is.
I wish it was.
Well, there's handwriting. We have here.
Shut it. I have some. And then. Cosine 3 times 5, 4. That's -1, right? One. That's just -2. Right.
It's good to me. Anybody disagree? 5 is A. Good job. Let me think of a question. Yeah, I can't think of one. Other than the way you calculated this, I think it can be done quicker if you think of the graph. Okay, think of the graph. Cosine looks like this. So this is pi, 2 pi, so 3 pi would be like that. You might get the value a little quicker and save a little time for another problem.
Yeah, I just always think of the unit circle.
Okay, there's nothing wrong with that. I'm just
Yeah,
trying to,
no, that's exactly.
all right. Yeah, I can't really think of any other hard questions here. So, all right, any questions about that? All right, Diego, you're up. Are you there?
Yep.
Okay, I'm gonna draw one for you. Number 14. Let's see. So you can tell me what to write and I'll write it, okay? This is number 14. Can you read it? It's a little small.
Yeah.
Okay. So this is one of those ones where it's modeling with differential equations, right? What do you think?
Just looking at the way it's set up,
Right?
how the initial, yeah, that, and how it's according, how it like it increased KY.
So we have, remember, another way of writing this is that the rate at which the quantity changes is proportional to the amount that there is. So you should be able to, just based on that description, rule out 2 of these 4 choices. Which 2 can you rule out?
Oh, are you asking me or everyone?
You.
Oh, C and D, right?
Yes, you can rule out C and D. We know it has to be something of the form A0 e to the kt. It has to be something like that. Does everybody understand that? That's here, right? This is the classic situation for exponential growth, right? If the rate at which it's changing is proportional to the amount that's there, that's exponential growth. These are the only 2 that are exponential growth.
Yeah, and then it would be B, right?
Why do you say it's B? How do you know it's B?
Well, so the initial is 120, right?
Right?
And 120 divided by 5 is 24.
No, the population is 120. So that goes
Oh,
here.
it's related off T. Oh, okay, yeah, my bad. Then it would be wait. A. If the initial 120.
We can phone a friend if you need help.
Yeah.
You need help?
Yes, please.
Okay, who's got any ideas? Yeah, what do you think, Phil?
So, yeah, I said it was A, because, like you said, A of 0 is 120, and then it says it's, and K is. I said K was 24, and you did.
What makes you think K is 24? It says that it's increasing at the rate of 24 grams per day.
Because if you, so what I did is if you, set it all up, so you have like y equals, 120 to kt.
Yeah.
But then you know that at t equals 0, the total population, which would be y, is 120, so you do 120 equals.
So if this is 0, then you get 120 no matter what K is. Do you know what I mean?
Yeah.
You guys think? Yeah, go ahead, sorry.
Find K, don't just use the dy over dt.
Okay, how so?
So you know, it's thinking of a rate of 24 grams per day, so that's dy over dt, and that's equal to 120K.
dy over dt at the point 0, 120 is, if you substitute 0, 120 in here, you get K times 120. And you know that that has to equal 24. So K is actually equal to 1/5. It's choice B. Does everybody understand that? This is a tricky question. You understand, Diego?
Yep.
Okay, everybody understand that? This is a tricky question. I don't think we've seen one exactly like this. What we have seen is ones where they gave you two initial conditions. Like they would give you a t and a y, and then a different t and a y, and then you use like a system of equations to solve for a, 0, and k, right? That's the type of question that we're used to seeing. This one's a little bit different for sure. Okay, so 14, let's just verify that. Should be B, it's B, okay? Any questions on that? Those are the tough one. Okay, who's next? Logan. He's gonna have to go twice tomorrow. So Molly.
Six.
Okay. 6 is. You can use side scrap work if that helps. Wait, how'd you get to 127? Oh yeah, I see.
Okay, I was like, I added one.
Yeah, but it's minus 3 plus 1, so it'd be minus 4.
No, that's minus 2. The plus 1 is already distributed.
So we have to distribute that negative.
The negative is already
I
distributed.
did it at the first step.
It's a negative,
First thing
and
I
she
did.
distributed the negative to make that a positive.
You do that right at the start.
Easier just to do that than have to do it another time.
Yeah, you're right.
All right, so you're taking the test. What do you do?
Yeah, oh my God, I don't know.
Yeah, let's do that, yeah. Good. Now, let's just check that. Yeah, that's good. Okay, so just the way I would have done this in my head is think of money. Like if you have
Oh, yeah.
75 cents minus $1.25, it's like negative 50. And then that would be a little easier. Now, how would the question be different if it said, what's the average value on the closed interval? Good, yeah. Any questions on this problem? Okay, good. Next. Jables. Very responsive. You can't choose. You can't do that. There you go, put that down. Great. How with you? Right. Does anyone disagree? Everyone agrees? Everyone got this one wrong then. This one is a lot like the question from the last test we took. If you have x minus 2 over absolute value of x minus 2, sometimes that's equal to 1, and sometimes that's equal to negative 1, right? Depending on whether x plus 2 is positive or whether x minus 2 is positive, or whether x minus 2 is negative. So if this stuff here is either 1 or negative 1, then that means the whole thing is sometimes 1/2 and sometimes negative 1/2. So maybe it goes like this, where it's negative 1/2 and then 1/2. Or maybe it's the other way around. I don't really know. I'd have to do a little more analysis on it, but I don't have to because I don't need to waste my time. Either way, it's a jump for sure. Does that make sense? Whenever you have absolute value of x over x, or x over absolute value of x, it's either 1 or negative 1. It's a piecewise function. This is, well, they're both the same. They're both this. Okay, well, that's a flipped circle. They both look like that, right? So this is the same thing, but just shifted over 2 units. So it actually is this one here. Does everybody understand why? You get it? Yep. All right. Let me just make sure about that. 20 is C, yeah. The jump discontinuity. Okay? That's something you should like try and just internalize and remember, because they test on that quite a bit, where they give you a fraction that looks just like that. Okay? And they're really just testing you to see if you know that fact. And it'll always be a non-calculator question. So you can check it out. Okay? Next. Luke. Well, right. That's 13. Okay? How'd you get that? Yeah? How'd you get that? Okay, so if this is free response, what would you write? Good, yeah. All right, does anybody disagree? So what if this is a little bit different question? What if they said that W of T is the rate at which the amount of water is changing, and they wanted to know how much water is there at time 3? Yeah, exactly. You take an initial amount, they have to give you an initial amount, plus the integral from 0 to 3 to get the amount of change, and that's it. Okay, so 12D is right. Any questions on that? Okay, good job. All right, that's all we have time for today. Is this helping? Do you feel like you're like learning a little? I don't know. All right, I don't want anyone to be nervous when it comes to be their turn. It doesn't matter if you get it right. It doesn't matter if you get it wrong. We're just trying to all help each other get them right when it actually counts, which is May the 4th.
What does that even happen? Like, it was really sad because the cover was nice.